Kirchhoff current law. Let's see. Algebraic sum of branch currents at node is 0 at all instants of time. That is, if you take the algebraic sum of currents coming to a node or present at a node, the algebraic sum is always 0 at any instant of time. That is, the sum of currents flowing to the node equal to the sum of currents flowing out of the node. That is, the algebraic sum of currents at a node is 0 at any instance of time. We have already discussed about the Kirchhoff voltage law in an earlier video. So if you want to know what is Kirchhoff voltage law for the simple explanation, just go to the description box. I'll share the link in my description box. Okay, so let's see what is Kirchhoff current law actually. I'm going to take a node here, that is A. I'm going to consider some currents. Say this is current I1, so it is flowing towards the node. I'm going to take current I2 flowing out of the node. I'm going to take current I3 flowing towards A, that is the node. Then I4 also, it is flowing towards, and another current I5 which is flowing from the node to some other nodes or some other point. Okay, so this is a node here. Some currents are flowing towards the node and some currents are flowing out of the node. So according to the Kirchhoff current law, the algebraic sum of the currents present at node A. So I am considering a node A here. The node A will be equal to 0 at any instance of time. So you have to consider a sign convention here to apply this algebraic sum. Okay, so we are taking that when the current is flowing towards the node A, we are going to give the current a positive sign. So if somebody is coming to the home, we'll welcome him or her happily, right? So the current here, when it is coming towards the node, it is given a positive sign. So if the current is flowing out of the node, so say a bye-bye and give a negative sign. Okay, so I'll write it here. So current flowing towards is given a positive sign, and current flowing outwards given a negative sign. That is flowing from and to. So if the current is entering, it is given a positive sign. If the current is exiting a node, the current is given a negative sign. Okay, so how can you write the equation of current present at node A? So let's see. Here I1 is current that is entering A, I2 is leaving, so I1 is given a positive, I2 is given negative, I3 is entering, so again it is a positive, I4 is also entering, so it is also positive, I5 is leaving the node A, so it is given a negative sign. So I'm going to write the current equation at node A. So I'll write it here. So I1 minus I2 plus I3 plus I4 minus I5 equal to 0. So this is the current equation of the node A. So how can you write it? If you simplify it, you can write again I1 plus I3 plus I4 equal to I2 plus I5. So what I have done is I have taken the negative currents to the other side. So this is a very simple thing. You can apply it in networks very easily. So this is the Kirchhoff current law. So now we are going to discuss a very simple example and simply we'll see how can we apply this in actual. So let's see. So this question consists of 3 nodes A, B and C. So there are various currents I1, I2, I3, I4, IR, I5, etc. So the values of current I1 is 2 ampere, I4 is minus 1 ampere, I5 is minus 4 ampere, and you have to find the value of the current IR. So the current IR is present in node C. So first let's write the equation for node C, the current equation for node C using Kirchhoff current law. So what is the current equation? Here the currents I3 and IR is entering the node C. And is any other current leaving? Yeah. Here there is a current I1 which is leaving the node C and it is moving towards node A. So you can write the current equation at node C as I3 plus IR minus I1, since it is leaving, equal to 0. or you can write I3 plus IR equal to I1. Okay, mark this as equation number 1. Now you don't know the values of I3. You know the value of I1, but you don't know the value of I3. Okay. So first we'll do something. We'll substitute the value of I1 here. That is I3 plus IR equal to I1 is 2. So you can simplify it again and mark this as equation number 1. Now you want the value of I3. So for finding that, let's look into node B and try to write the equation, the current equation at node B. So at node B, you can write I5 is entering the node, I2 is entering the node, and I3 is leaving the node. So you can write it as I5 plus I2 minus I3 equal to 0. Okay, since I3 is leaving, it is negative. So you can write it again as I5 plus I2 equal to I3. So this is your equation number 2. Again, you have the value of I5 here. You don't know what is I2. Okay, so I am going to substitute the value of I5. I5 is minus 4 ampere. So minus 4 plus I2 equal to I3. Again, this is my equation number 2. So you got equation number 1 and 2. And now you want to find the value of I2. Okay, so for finding the value of I2, I have to again write our equation for I2. So for that, I am going to write the current equation at node A. So in this node, what all currents are present? I4 is there, I1 is there, and I2 is there. So I4 and I1 is entering the node. So I4 plus I1. Now I2 is leaving. So minus I2 equal to 0. Okay, you can write it as I4 plus I1 equal to I2. Now you have the value of I4. Also you have the value of I1. See here, the value of I4 and I1 is given. Substitute the value of I4 and I1 and find the value of I2. I'll first mark this as equation number 3. Okay, so using these 3 equations, you can find the value of IR. First, I'm going to find the value of I2 by substituting the values of I1 and I4. So what is I1? I1 is 2 ampere and I4 is minus 1 ampere. So you can write minus 1 plus 2 equal to I2. This you have, I'm going to write it here, I2 equal to minus 1 plus 2 is 1. So I2 is 1 ampere. So substitute this value in equation number 2. The value of I2 is 1. So minus 4 plus 1 is equal to I3. So minus 3 ampere. So I3 equal to minus 3 ampere. Now you got the values of I2 and I3. So you want the value of I3 here. Now you have the value of I3 equal to minus 3 ampere. I am going to substitute this I3 value in my equation number 1, this equation, and I am going to find the value of my IR. So substitute, that is minus 3 plus IR equal to 2. So IR equal to 2 plus 3, which is equal to 5 ampere. So this is your result. So you have to find the value of your IR and you got it as 5 ampere. So here you have applied the Kirchhoff current law to simplify this network and find the value of your current. So this is how you can apply Kirchhoff current law. This video is a very quick and simple explanation of Kirchhoff current law. So I hope you enjoyed watching the video and you understood what is Kirchhoff current law. Please do share this video with your friends and family and also do subscribe to the channel. Thank you.